Hey, so here is the second part of that video because I was getting close to my limit and YouTube cuts me off. But um, the effect of dilation. So when you have a scale factor and you're dilating a figure, what happens to the perimeter and area is what we're talking about. Hopefully you have your notes and you've been writing down the key concepts. And so just a review, so we're all on the same page. If you are dilating a shape, whether it's an enlargement or a shrink, the perimeter is just going to be multiplied. The perimeter is going to be multiplied by the scale factor to find the new perimeter. And the area is multiplied by the scale factor squared to find the new area. Just don't forget, that's what a lot of people forget. You have to square the scale factor. And watch the other video if you are still confused about why we square it. But we square it because it's different dimensions. Uh-oh, my phone is beeping. So, example 3. I'm going to read it from the paper because I probably abbreviated. The Clydes have a 5-foot by 8-foot porch on the front of their house. They are building a similar porch on the back with double the dimensions. Determine the area of the back porch using scale factors. So first let's identify what our scale factor is. And it says double the dimensions. So our scale factor is 2. Now, because in this problem we're talking about area, let's just go ahead and decide, are we talking about perimeter or area? We're talking about area, so we need to square the scale factor. So we're going to be dealing with a 4, quadrupling the area instead of just doubling it. The dimensions are doubled, but because we double both the length and the width, we actually quadruple the area. So we need to find the current area of the front porch. And so the front porch is 5 feet by 8 feet. So the area would be 40 feet squared, or 40 square feet for the front porch. But the back porch, we need to quadruple that. So we're going to take the area, 40, and we're going to multiply it by 4 because it's the scale factor squared. And 40 times 4 is 160 square feet, and that would be the area of the new porch, or the back porch. So this is the area of the back porch. And if you are visual and you want to draw a picture, then go on ahead. The new porch would be at 10 by 16, because the front porch was 5 by 8, the new porch would be 10, that's a 16, but it's hard to see. And if you actually double the dimensions and find the area, it still is going to be 160. But the problem specifically says determine it by using the scale factor. So we just want to make sure you understand the process of what the scale factor does to the area. All right, I know it's really sunny in my classroom, so I'm sorry about that. Example 4, Clayton is constructing a miniature putting green in his backyard. He wants it to be similar to the putting green down the street, but 1/3 the dimensions. So 1/3. The area of the local putting green is 1,134 feet squared. What will the area of Clayton's putting green be? Use the scale factor to compute this area. So in this problem, the similar putting green is 1/3 the dimension. So our scale factor is 1/3. But because we're still talking about area, we want to square that scale factor. So when you square 1/3, you get 1/9, because 1 squared is 1 and 3 squared is 9. So you get 1/9. Now, we need to find the area of the current putting green, the big putting green, but the problem already gave it to us. The area is 1,134. We're going to multiply that by 1/9. So 1,134 times 1/9. If you're using your graphing calculator, make sure you type it into parentheses. Multiplying by 1/9, though, is the same as dividing by 9, so you could just divide by 9. And when you multiply this by 1/9, the area of Clayton's putting green is his miniature putting green is 126 square feet. And so that is the area of his putting green for his mini putting green, similar to the one down the street. So again, you have to identify your scale factor. You have to know if you're talking about perimeter or area, and then you can multiply by the scale factor. Okay, examples 5 and 6. Okay. Example 5, triangle LMN is similar, remember this symbol means similar, to PQR. Perimeter of LMN is 64 meters. So I just have two triangles here. We're going to call this one LMN and PQR. They are similar. So the perimeter is 64 meters. What's the perimeter of PQR if LM, this line right here, is 24 meters and PQ is 18 meters? So what is the perimeter of PQR? Now, I know that this line is 24 and this line is 18. So I know that this dilation was a shrink. We started a little bit bigger and we got smaller. But my question is, what is this perimeter? So I first have to identify the scale factor. So this is a good review. To identify the scale factor, we need to set up a ratio of the dilated figure compared to the original. So my dilated side is 18 to 24. That's how you're going to find the scale factor. You're going to compare the new figure, the dilated figure, the image, compared to the pre-image. So I'm going to reduce this, and I can divide them both by 6, and I get 3/4. So my scale factor is 3/4. So that's part of it. We need to identify the scale factor. Now the next thing we're looking for is the perimeter. So if you need to, go back and look at your notes, but to find the perimeter of a dilated figure, you're going to multiply the original perimeter just by the scale factor. And you don't square the scale factor, you just multiply it. So my old perimeter was 64. I'm going to multiply it by my scale factor to find the new perimeter. And so when you type this in, don't forget to use your parentheses, but when you type this in, my new perimeter is going to be 48 meters. So that is the perimeter of my new triangle. I don't square it because it's perimeter, and perimeter is not in squared units. It's only just in regular units. Okay, you have a U try right here. So 3 rectangles are similar. The larger one is 3 times the size of the middle, and the smaller one is 1/3 the size of the middle. The middle rectangle has a perimeter of 30 inches and an area of 27 inches squared. Find the possible perimeter and area of the small and large rectangles. Now, I don't have a room right here to show you, but I am going to show you. So pause it. You work it out on your own. Now, if you want to draw pictures, good. You would have 3 rectangles, a small, a medium, and a large. If you aren't going to draw pictures, then that's fine. You can do this both. You can draw pictures. You don't have to. But the information was the perimeter was 30 inches and the area was 27 inches squared. The scale factor here was 3 and the scale factor here was 1/3. It said, the problem said, the larger one was 3 times the size and the smaller one was 1/3 the size. So going this way and going this way. That's really all you need to know to find the perimeter and area of these rectangles. That's kind of small, so I might come up below. So let's do the bigger one first. Remember, perimeter, the scale factor is not going to be changed. You're just going to multiply the perimeter times the scale factor. So for my big rectangle, the perimeter is 90. I'm going to do the area of the big rectangle. For area, you have to square the scale factor. So my old area was 27. My scale factor is 3, so I'm going to square it. So 3 squared is 9. So this is 27 times 9. And I'm going to get 243 inches squared. So those are the new perimeter and area of my enlarged rectangle. I just took the scale factor and I multiplied the scale factor times the perimeter and then the scale factor squared times the area. So now let's go down to our shrink, our smaller rectangle. The scale factor is 1/3 because the problem said the smaller one is 1/3 the size. So I'm going to multiply 30 times 1/3 because with perimeter you just keep it the same. 30 times 1/3 is 10. So my new perimeter is 10 inches. And then for area I have to square the scale factor. 1/3 squared would be 1/9 because 1 times 1 is 1, 3 times 3 is 9. I'm going to do 27 times 1/9. And again, it's just like over here, we squared it, but the scale factors were different. So 27 times 1/9 is 3 inches squared. So this, hopefully you got this, you try, but this is showing you how to use your scale factor to determine new perimeter and new area, and we will work more about this in class.